Okay, page 6, 1.8, decimal forms of rational numbers. So before we discussed that a rational number is any number that can be represented as a fraction using whole numbers. So whole number in the numerator, whole number in the denominator, boom, rational number. At the top we have a few decimals now. Decimals can also be rational numbers, or I should say rational numbers can also be expressed in decimal form. So our first example there is 0.7, which means, what? In words, let's convert it to words. 7 tenths. 7 hyphen tenths. And now that it's in words, it's really easy to understand that 0.7 can be written as 7 over 10. That is a fraction where the numerator and denominator are both whole numbers, or both integers. That's the rule, integers, not whole numbers, because it can be negative as well. So integers. Good. Next one, 0.45 means 45 hundredths. 45 hundredths. And yes, there's a hyphen in between each of those words. 45 always gets hyphenated, a two-digit number. And then hundredths if you have a portion of it, or if it's a decimal, then you use the hyphen as well. So 0.45 equals, as a fraction, 45 over 100. And this would work the same with negative numbers, as we'll see in the next one. If we had a negative 0.45, we would say it's negative 45 hundredths, and it would be equivalent to negative 45 over 100. The next one is a little bit longer. It's negative 1.875. Negative 1.875. Who would like to try that in words?
Negative 1 and 870.
Yeah, you kind of tailed off at the end there, but keep going.
Negative 1 and 875.
875 thousandths, right? So in order to save space here, I'm not going to write the words 875. I'm going to say and 875. We'll write the word thousandths. And then there's going to be a couple different ways to write it. The first is going to be a mixed fraction. What would that look like?
1 and then 875 and then a line and then 1,000.
Nice, and let's not forget
Negative.
our negative sign. So we're going to have negative 1, and then in the numerator 875, in the denominator 1,000. What about as an improper fraction?
1,875
Nice, we'll put our negative sign out in front again, and then in the numerator we have 1,875 over 1,000. So something here has been split into 1,000 parts. You have one whole, and then 875 parts of another. And that's easy to see here in the mixed number.
Put that over 10,000?
And it's a negative.
No.
Nope.
Why?
The question was asked, should I put this over 10,000 instead? No, because I have here one whole. So if it was over 10,000 and I only had 1,875 of them, I wouldn't have a whole anymore, right? I'd have actually much less. So the denominator won't change. If it says 875 thousandths, then we're dealing with thousandths. Okay? Here shows I have negative one whole and then some more, and this shows the same thing. I have more than one of these things.
But you could do it, right? Or is it not allowed?
You could represent, remember, any rational number can be represented as a fraction using integers, and we can find equivalent forms for any number. Any number can be written in another form. So realistically, yeah, you could multiply the top by 10 and the bottom by 10, and then that would give you a fraction over 10,000, but it wouldn't be 1,875 anymore. It would be 18,750. Okay, all we did there is multiply top and bottom by 10 to make sure we still have the exact same value. And to get it back, all we could do is divide the numerator and the denominator each by 10 again. and we get back to the same number. Okay? So you can't just add a 0 to the denominator. You have to do something, and if you do something to it, like multiply by 10, you have to do the same to the top. Okay, these examples that we just wrote about and talked about are called terminating decimals. Terminating decimals. Why are they called terminating decimals? Yeah, they end. That's easy. Terminating means end. Here we had 0.7. I don't need any more information in this decimal to represent 7/10 perfectly accurately. Same thing here. 45 over 100 can be represented perfectly as 0.45. And the same situation down here in our bigger number. But there are also numbers that are not terminating decimals. So go ahead, in your next step, go grab a calculator. If you don't have your calculator, go get it really quickly, please.
Can I borrow one?
And what you're going to do is simply
Calculator, my best friend.
punch that into your calculator as 4 divided by 9 and see what you get. And then D, you're going to do 7 divided by 11 and see what you get.
So obvious.
Continual, that's a good guess. Okay, so here we have our answers for A and B. You can double check. And I just did a little ... because I really just want to show what the calculator is telling me it is. Some of you are saying, hey, why don't we just do it this way? Put a bar on top. That's called bar notation. We're going to write a little note about that later. And it indicates that there is a repeating decimal. So these are called non-terminating decimals. Non-terminating decimals. They never, ever, ever end. Now don't be tricked, because they're still rational numbers. Right? And that's our next part. So they're non-terminating decimals. And they are still rational numbers. How do I know that they're still rational numbers?
They can be expressed as a fraction.
Because they can be expressed as a fraction.
And they don't end. Using whole numbers.
And we're going to use integers, using integers.
How do you figure it out if you're given the decimal for that? How do you figure that out?
So the question is, how can I figure out if it's a rational number if I'm only given the decimal form? Well, what do both of these examples have in common? What does 0.444444 and 0.63636363 have in common?
They repeat.
They repeat. So if you're ever in a situation where you have a repeating decimal, you know that it can be represented as a fraction using integers. It is a rational number. Even if that repeating, even if the cycle of repetition is 5 digits, you can still know that it's a rational number. Now there are decimal numbers that do not repeat ever. Do you know an example?
Pi.
Okay, pi. 3.14 ... Okay, it goes on forever and ever, and there's no repeating. Not a rational number. It's a real number, but it's irrational, which we talked about a little bit the other day. So you have a chart there, and you're asked to complete the table. You're given the fractions. You have to print the division that you type into your calculator. Then in the next box, show what your calculator shows, and then simplify it into decimal form. So you'll notice in the top box, in the top row, 3 divided by 8, the calculator will get 0.375. You can't reduce that using bar notation. The final box there is also just 0.375. But for instance, 1 divided by 3, your calculator will churn out 0.33333333333, which you're not going to write on a test or on your homework. You would write 0.3 with a dot or a line over top of it to indicate that that decimal does indeed repeat. Go ahead and try those on your own, and we'll check our solutions with a neighbor to see if we got them all correct. You can double check the last column of your answers on the board. Notice there are a couple with bar notation, which means they're repeating decimals. And that's the note that we're writing right now. In the chart, the decimal form, yep.
For 5 divided by 11,
Nope.
it's 4545455.
So again, the calculator, once it runs out of space, it will round up or down. It will round to the nearest whatever in order to say, hey, this is close enough, you can use this number going forward. But the calculator will display that, but if you use it again, like if you do another operation without changing what's written there, it will use the real answer, not the rounded answer, if that makes any sense to you. But anyway, in the chart, the decimal form of 1/3 is an example of... What's this guy an example of, the way we wrote that? What kind of notation?
The non-terminating bar. Oh.
Bar notation. Bar notation. And when can we use bar notation?
Bar notation.
For decimal.
What kind of decimals?
For repeating.
Non-terminating.
Repeating decimals. Now, not all non-terminating decimals are repeating, right? Some decimals go on and on and on, non-terminating, and don't repeat. These are special cases where the decimal goes on and on and on, but it repeats itself at some point. And we can use bar notation for that, and those are also all examples of rational numbers because they can be represented as fractions using integers. Your practice problems for lesson 1.8, no calculator allowed, can be found on page 136, number 4 through 13, and 35 through 61.